Here's the other bit. You also get bottom Ekman layer. So yeah, how do you get a bottom Ekman layer? It's like what you need is you have to have a flow above the seafloor, a horizontal flow, which is shown here in this sketch, interacting with the seafloor, and then due to frictional effects, you get a bottom Ekman. So why? I mean, this problem is pretty much equivalent to the situation of having a wind stress above an initially fluid at rest. What you could imagine is you turn this problem upside down, and instead of moving the fluid, you can actually move the seafloor. Yes, and then the seafloor friction operates similar to wind stress. This is how to see it. Again, you can use the same model to actually simulate bottom Ekman. Okay, so what you do, you have the same equations, and there's a little trick of how can you now formulate your currents with as a difference to this ambient horizontal flow field. It has components called UGeo and VGeo, ambient uniform flow, and then you can work out again using boundary conditions, no gradients across the sea surface, and so you can simulate the current in the bottom end. And you can use, again, listed here are the physical parameters. For this example, I used a ambient flow field, just flow in the y direction again, VGO 10 centimeters per second, and all the other parameters I think are the same as. And then again, you can use a Lagrangian floats to visualize the solution. Here we are. Here's the solution. So the red one gives you the displacement caused by the ambient flow. And then all these blue dots here are particles, particle displacement, and shows you the structure of how does it look like as you move towards the sea. Okay, the last one is 1 meter above the sea floor, 2 meters, and you can see that the direction within this bottom Ekman changes as you reach the sea. Typical thickness of Ekman bottom layer is something like 10 to 20 meters. These ones are so-called bottom Ekman. It's pretty cool that you can actually very precisely model these Ekman. Okay? It's a little bit tricky because you have to learn about how do you treat the Coriolis force, and you have to learn a little bit more about